Okay, 4, 3, multiplying and dividing rational expressions. Rational expression is a fraction that has equations in it, right? We are just going to, well, okay. I want an equivalent expression. What does equivalent mean? Equal. Okay, so I'm going to start with, give me the equation. X cubed minus 5x squared minus 24x over x cubed plus x squared minus 72x. Now, when she said equal, I said, oh yeah, okay. Not really though. Equivalent means, like, remember when we had triangles and the object was congruent, the numbers were equal, right? So that you can have a side equal to another side. You can have a side length equal to another side. Makes sense? Okay, so these are not going to be equal in the sense that they look exactly the same, but when I plug numbers in them, I'm going to get the same exact answer. Does that make sense? Yeah. Okay, so what do you think I should do with this rational expression?
I want to take an x out.
You want to factor an x out?
Yeah.
So when you look at it, you're right. You should look at the top as one thing and as the bottom as one thing, and then you can look at it as a whole. Okay? So yes, you should say, I want to factor an x out. Why? Because they have an x. Okay, so if I factor an x out of the numerator, so I have x, and then I would have x squared minus 5x minus 24. Could I factor that? That's why I didn't write it here.
Like for 20, what equals?
Factors of 24 that have a difference of 5. 8 and 3. So it'd be x minus 8 and x plus 3.
Yeah.
Okay. And basically what I'm doing is step 1 on graphing rational expressions. We simplified, right? That's what we're doing. We're just simplifying it into something else. So now the denominator, I could also factor out an x, yes? Mm-hmm. And that would be x squared plus x minus 72. Can I factor that? Factors of 72 that have a difference of 1. 8 and 9. The 9's positive?
Mm-hmm. Yeah.
Okay, so I've factored them both completely. What could I do with them?
Can't you factor out the x minus 8?
I can reduce out?
Yeah.
Because the whole thing will reduce, so I can reduce it. When we have quantities, if the whole thing doesn't reduce, you can't reduce, right? Whole thing. What about the x's?
Yeah.
Hate crossing out x's. How do you cross out an x? Make it a star? I don't know. Bothers me.
What?
Okay, so all of these reduce to 1 times x plus 3, so I have what? X plus 3? And over x plus 9. Now, if you were a person that is tempted to reduce this, put them in parentheses so you don't reduce it. Because it is a quantity, and unless the whole thing reduces, you can't reduce it, correct? Mm-hmm. So, what we've done is this expression is equivalent to this expression. They're equivalent.
Oh, that's all you do?
Yeah. Haven't we basically been doing that?
Oh, yeah.
Yeah.
All right, let's stop.
Now,
Can they not be equivalent at some point?
well, they just want you to make an equivalent expression. Like, you know what I mean? Sometimes they won't factor. But you can also make an equivalent. Could I do this? This would be equivalent to... Well, what did I do from here to here? I didn't make it
Times by
smaller.
6.
I multiplied the numerator and the denominator by what?
6.
6. So if I reduced everything, would it still end up this?
Yes.
So there, I can make equivalent things by dividing, which I did, because reducing is division, yes. Reducing common factors. I'm not doing long division and having remainders. I'm reducing common factors. Or I also can multiply. So if there's no common factors to reduce, then you could multiply. Okay, I think that's what you're asking. Okay. So, writing equivalent statement to my brain is just basically simplify it. And if it won't simplify, then I have to multiply it by something. But whatever I multiplied the numerator by, I had to multiply the denominator, so they would stay equivalent. You can't multiply and change it. Simplify. 4 minus x squared over x squared plus 3x minus 10.
The top is a perfect square, isn't
It's a difference of squares, yeah?
it?
So it's going to be 2 minus x into plus x. So basically you initially looked at it and said, I need a factor, yes?
Mm-hmm.
That's what you need to do. So the denominator,
5 and 2.
which one's negative?
2.
Okay, so negative 2 and 5. Can we reduce anything?
The x minus 2's.
Okay, you want to, correct? Because the top is x, or 2 minus x, and the bottom is x minus 2. Are they exactly the same? No. If it was addition, could I just reduce them?
So can we not like?
Well, what could we
switch the X
do?
and the 2?
We could, yeah, that's what I'm asking. We could switch it. So if I took this right here, I could make it negative x plus 2. So now I have it in the right order, but I want a positive x and a negative 2. So how do I accomplish that?
0 it out. Do the other one?
Could I factor a negative out?
Yeah.
Couldn't I?
Yeah.
So it'd be negative x minus 2. And now this other one, can I just write x plus 2?
No.
This one?
Oh, you can.
Yeah. Because it's addition, and addition's commutative, right? And then I have x minus 2 and x plus 5. So now can I reduce?
Yes.
Yes. Now I can reduce, but I still have a what out here? A negative. Don't forget it. So my answer would be negative the quantity x plus 2
Over x.
x over x plus 5. And leave those parentheses around there. Give yourself a chance not to, like, your brain not to want to reduce it out. Want to do one on your own?
Sure.
Ooh, we're going to go big time on you.
Hey, no.
Okay, x cubed plus 4x squared minus x minus 4 over x squared plus 3x minus 4.
Can I factor by grouping?
Yep, if it works. Can I start? You guys far enough along? Remember to factor all the way.
Yeah.
What's wrong, Olive?
Hmm?
What's wrong?
I don't get how you do the top.
Okay, so I factored by grouping, so I took out a x squared and have x plus 4. Always take that sign, right?
Oh.
So negative, and so be x plus 4. Did you forget to take your negative?
No, I just didn't know you could do the grouping thing.
Well, if there's 4, that's the only method you know
Right.
other than long division. Cooper, how'd it go?
I'm good.
What don't you get, sir? Did you factor it?
No.
Did you know you should be able to factor this by grouping?
Oh, yeah. How do you do
If you just look at the top?
that? The X.
I did not.
Mhm.
No, I did not. do
Okay.
anything with the top.
When we have 4 terms, the only method you know besides long division is factoring by grouping. Yes? So anytime you have 4 terms, you should just try factoring by grouping. That should be your go-to. So I factored an x squared out of the first 2 terms. Always take this sign, so it's a negative, so then I get x plus 4. And the denominator, did you get x plus 4, x minus 1? Get that? Okay, so then I've got x squared minus 1, because there's a 1 here. And x plus 4, so the x plus 4s reduce, but x squared minus 1 is a difference of squares.
Yeah, I feel like
So x minus 1, x plus 1, and then I can reduce out the minus, and I get down to x plus 1. So keep
I just got
factoring.
confused by the 4 up top.
Yep, just remember the only method you guys know is factoring by grouping. Okay? Alex, does that fix yours?
Yeah.
Cole, how'd you do?
Fine.
Fine? Okay. And I know a couple of you forgot to keep going on your factoring. Just make sure you keep going, okay?
I got
It-
my denominator good, but
Good. So it's just like if I told you 20 tenths, and you told me no 20 80ths. If you told me that was 10 and then 40ths, that's not a wrong answer, but is it done? No. That's what, if you would have stopped after this, if you would have just had x squared minus 1 over x minus 1, it wouldn't have been wrong, but it wouldn't be done yet. Okay, are we pretty good on simplifying, you think?
yeah.
You know what you're supposed to do? Okay, so multiplying. So we multiply 2xy over z. And they just say and I'm going to write it that way for a second so you can see. 3x squared over 4yz. Okay, how would I write that and? Like multiply them. How would I write the multiplication? Would I put an x? No.
Dot.
I wouldn't put a dot either. I'd put a what? Parenthesis. Because if you put a dot, I'm going to write a dot. Just watch when I do. X, y over z. If I just put a dot, oops, that's a 3. Your brain could see that dot and go, ooh, subtract it. Couldn't it?
Yeah.
Okay. But if I do this, is it very clear what I'm doing? Yes. Now, remember when I multiply fractions, we are to reduce before we multiply, yes? Because we multiply across. So we can multiply up or down, or what? Diagonally. And honestly, when you have a multiplication of fractions, watch this. Don't you just have one big fraction?
Yeah.
Yeah. Okay, so what can we reduce? Can we reduce a z and a z?
Yeah.
Oh no, We can't reduce a z.
Can we reduce the x's?
Nope. We can do up and down or diagonally.
The y's?
Oops. Y's we can. What else? What about 2 and 4?
Oh,
Yeah. So it gives me 1 and 2. I typically don't put the 1s because then my brain doesn't want to add them because it's all multiplication, right? So do I have anything else I can reduce? Nope. So now I just multiply across, right? So I'm going to have 3x to the third over z to the second. So did I have to actually divide in order to multiply?
Yeah.
Yeah, because you had to reduce.
What happened to the 2?
Oh, I just forgot it. Just forgot it. Sorry.
I was going crazy.
Well, you know. We didn't want to say anything. In the book, they have a dot. Okay. Should we use dots?
Oh.
No. Bad. I'm not going to even use dots in the example. Okay, so our next one is 5x over x plus 3 times, parenthesis, x squared plus x minus 6 over x squared plus 2x plus 1 times,
Oh my gosh.
can we keep going all day?
No,
Yeah.
we can't.
Yes, we can.
Because we gotta get out of this class sometime.
Over 5x minus 10. So on the first one, I gave you whole numbers that they were multiplied. I didn't give you quantities, did you? Did I? No. I'm actually in my brain I'm not in my brain. On my paper, I'm gonna put the x plus 3 in parentheses so I remember it's stuck together. Yes? Would that be a good idea? Yeah. So what do you think I should do here? Should I just start multiplying?
No.
No. What should I do?
Simplify.
I should simplify first, right? And in order to simplify, I need to factor.
Factor all that.
So, well, this one's taken care of, isn't it?
Yeah.
Okay. Well, factors of 6 that have a difference of 1.
3 and 2.
Okay, so x plus 3, x minus 2. Denominator, factors of 1 that add to 2.
1 and 1.
So x plus 1. Do you want to put quantity squared or you want to put x plus 1 times x plus 1?
Quantity squared.
Let's just do 2 parentheses.
I'm going to say let's do 2 parentheses because then maybe only one of them can reduce out. Does that make sense?
Yeah.
You could do it with exponents, but sometimes it's easier like this. Okay, and then what about the numerator of the next one?
Take an x out.
I can factor out an x, and I have x plus 1,
You can take a 5 out of it.
and you can factor out a 5, and have x
Minus 2.
minus 2. So once I've factored that, I can again reduce up and down, or what? Diagonally. Now, does it have to be in the rational number right next to it? No, it can be a couple away, can't it? Okay, so what can we reduce?
The x plus 1.
X plus 1 and x plus 1? Too bad there wasn't 2 of those, right? The reason I did this is sometimes when we put x plus 1 squared, somebody will do it and reduce out the whole thing rather than just the squared.
And can you factor out the x minus 2?
The x minus 2.
And the x plus 3?
X plus 3.
Just not all. You ready to do it? Oh, can you the 5? fives?
The 5s can reduce, can't they?
So then it's just x over x plus
So it's just x right here. And this is 1 and 1 and 1. Oh, but we got another x. So my numerator is what? X times
x squared.
x squared. And my denominator, the only thing left is what?
X plus 1.
X plus 1. So when you multiply, are you really simplifying, dividing all in one?
Yeah.
Yeah. Do you guys want one on your own?
Yeah.
I guess, Miss Matt.
I know, I'm horrible. Okay, x squared minus 16 over 9 minus x. And again, they're going to have dots in between those, but I would
Can
not.
we, reorganize the x and the 9?
As long as you take the signs,
Oh,
like it would be negative x plus 9,
oh yeah.
right?
Yeah.
So you can change around subtraction, but you got to take the signs with them, right? You do in addition too, but they're both just positive. And then x squared plus x minus 90 over x squared plus 14x.
Minus 90?
Yes, did I say plus?
Yeah.
It's minus. And plus 40.
Is that it?
I don't appreciate the big numbers. Miss Matt.
Not that. Really, the factors of 90 that have a difference of 1.
I'll tell you.
Really? Okay.
Please read it quickly today.
Cooper, you got it done already?
Yes.
No one believes you. Did you factor?
No.
Please do.
Can we factor up and down? Like,
You mean reduce?
yeah.
Yeah. Factor up and down. No, you cannot do that. Weirdo.
They have to be exact same to,
They have to be exactly the same to reduce.
like, not even a negative difference.
Uh-uh.
I think I do it.
Unless you do what we did on the other one.
What are we doing the other one?
Exact same.
I'm assuming y'all got there pretty easy.
Mm-hmm.
And Alex is wanting these two.
Yeah, I took it.
So
Negative.
it's negative x plus 9. And yes, if we factor out that negative, do we have x minus 9?
Yes.
Yes. But don't forget what?
The negative.
The negative. That negative 1 makes a difference. Because the only thing we have in the denominator is negative 1, isn't it?
Mm-hmm.
And I don't think we really want to write an answer like this. Do you?
Yeah, I don't know.
That's weird, right?
I mean, I put that and I was like, what?
Yeah, it is weird. So in order to get rid of the negative, I have to multiply the numerator and the denominator both by negative 1, yes? So negative 1, negative 1. And remember, it's still quantity on top. So now the denominator is just 1.
And on top is
And the top is negative x
plus
plus 4. So I'm going to write it 4 minus x. Why did I write it 4 minus x?
It looks better.
Looks better, and I'm not going to forget my negative, am I? No. So, Alex, unless you move it around and factor out, then no, you may not. But if you don't, then you're not completely done. So it's good that you're saying, wait a second, I should be able to do something with these. We just have to remember how to do it. Okay. Now, they put this in a separate section, and I don't really know why it's a separate section because I don't see it. I see it as exactly the same thing. They have x minus, plus 2, excuse me, over x squared. Oh, no. X to the 4th.
Whoa, you aren't using your magic pen?
I know. I got these and they were drying out, so I'm like, I probably should use them. X to the 4th minus 16. And they just have it times x cubed plus 4x squared minus 12x. So is this any different than what we just got done doing?
Mm-mm.
No. The second polynomial, the denominator is just what?
1.
1. So it really doesn't matter. I need to do what with it? Factor it. And I'm going to just make me one big division bar. So I'm going to have x plus 2 as a factor, right? So then we're probably going to factor out an x, aren't we? Yeah?
Yeah.
And so that would give me x squared plus 4x minus 12. What are the factors of 12 that have a difference of 4?
6 and 2.
6 and 2. So we're going to have x plus 6 and x minus 2. Now, I am going to write this differently down here at the bottom, though. I'm going to write the x in the front of all of it, and x plus 6 and x minus 2. Does anybody guess why I put that x clear out in the front of all of it?
It goes in all.
Well, it doesn't go into all of them. It's multiplication, yes? So can I write it in any order? And I really didn't want to put, like, parenthesis x in the middle of all that. It would look funny, wouldn't it? So I put out front. Okay, so now I need to factor this, don't I? So it is a difference of squares. It's just not the square you're used to, right? It's not going to be x. It's going to be x what?
Squared.
Squared. So it's going to be x
Minus 4 plus 4.
x squared minus 4 plus 4. Now, am I finished factoring?
No.
No. Why?
Because of the x squared.
Because I have this right here, don't I? Now, can I factor this one? Not unless I'm going to make imaginary numbers in there. You want imaginary numbers in there?
No.
No. So we can't factor it because that's not the difference of squares. It's the sum of squares. Okay, so my numerator is still x plus 2, x plus 6, x minus 2. What's the denominator?
X minus 2x plus 2 and x squared plus 4.
Yep. X minus 2, x plus 2, and x squared plus 4.
Plus 4?
So, minus and plus 2's go out, right? Is there anything else?
No.
No.
No. Nothing else. And so my answer would be x times x plus 6 and x squared plus 4.
That's it?
Was it?
Mm-hmm.
Was it any different? No. Just keep factoring, right? Put a 1. Okay, now we're going to divide. real quick review before we start. When we divide fractions, what do we do?
Multiply by the
Reciprocal.
reciprocal.
Of which one?
The second?
The second one. So it'd be 1 over x times y over 1, which would be y over x. Yes? Does that change just because it's a rational expression? Nope. Okay, so I have x cubed plus 3x squared plus 3x plus 1 divided by 1 minus x squared. Now the whole thing is divided by x squared plus 5x plus 4 over x squared plus 3x minus 4. Now, if the whole polynomial was the same, could I reduce it?
Yeah.
Yeah, I could, but it's not. Now you guys know why I pushed you on factoring so bad?
Mm-hmm.
Yeah. Okay, so what do I need to do?
Simplify.
I need to factor and then simplify, but this division is going to turn into a what? Multiplication, and I'm going to switch them. Okay, so what am I going to use to factor this first one?
Factor by grouping.
Factor by grouping. So I'm going to factor out an x, and I don't know why I did it this weird way. Squared. So I have x plus 3. Always take out this sign, so plus.
Wait. You need to get an x again. I know you can't. Plus 3x plus 1.
Well, I would only be able to take out a 1, right?
Mm-hmm.
What's wrong with that?
They don't equal the same.
It doesn't equal. So did that work?
No.
No. Okay. I don't have to group the first two and the second two, do I?
Can you group the middle
So
two?
should I try group in the middle two?
Yeah.
Okay, let's try that. So I'm going to have, I really shouldn't have done this. So I'm going to have x cubed plus 1. That's it, right? And then I'd have plus 3x, and then have x
Plus 1.
plus 1. Did that work out for me?
Closer.
It's closer.
Why can't we just take out? Oh, no, we can't.
Did that work for me? Just making sure I put it right. Did that work?
No.
Why am I know what it should be because I know this pattern. But why is it not working for me?
What if we try the other combination?
Well, I know this when we did. I know this is 1 plus x cubed.
Couldn't we do...
Like, that's what this is.
Well, what if we did x cubed plus 3x group... Or, yeah, plus 3x, group those, and then 3x squared plus 1. Then we get the same thing.
Thank you. Okay, so it didn't work to do these, but Olive says, what about these two and these two?
Easy.
Do they work?
Yes.
Yeah? Okay, and I've got a bunch of crap. I'm going to get a new piece of paper and put under it because that's too much crap to look at, right? Now, what's bad is my brain didn't want to see it because did I already know the answer? Yeah, you guys didn't know the answer, did you?
Yeah, I did.
You did not. Okay, so we're going to group the first and the third. So we're going to take out an x and have x squared plus 2,
Plus 3.
plus 3. And then these two,
Take out a 3.
no, can't take out a 3. You can only take out a 1.
Oh, so no.
So we'd have x squared plus 1. Yes?
Oh, yeah. Yeah, but there's a 3.
Oh. Which is not the same thing, is it?
Well, can't we just...
There's a FFA meeting today during senior high IAP in room 108.
Okay, I'm going to have to think of how to explain it. But this is what it is. 1 plus x cubed. My brain is not thinking. Lack of oxygen. I'm going to tell you it is. If we multiplied it all out, we get this, okay? I promise you. Okay, can I factor this? 1 minus x squared?
Yeah.
1 minus x, 1
Hold those.
plus x. And in order to change it to multiplication, I'm going to reciprocate. So I'm going to factor the bottom first. Factors of 4 that have a difference of 3. So x plus 4 and x minus 1. Okay. Factors of 4 that add to 5.
4 and 1.
So x plus 4
X plus 1.
and x plus 5. So now, oh, plus 1, yes. So do I do anything different now with this? Nope. Okay, 4 and 4.
Negative 1 and 1.
Nope. We got to rearrange this one.
Shoot.
So it'd be negative x minus 1, right?
Take out a negative.
So we have the negative still, and now can we reduce that out?
Yeah.
Yes? Now, I have 3 1 plus x's, and I have 1 x minus 1.
X plus 1.
X plus 1, sorry.
Let's just take out the 1, and then can't we just put 1 plus x?
Well, it's addition, so can't I just move it around?
Yeah.
Yeah? Oh, and I should have written x plus 1, but it is addition, so is it commutative? So I'm taking one of them, so I'm still left with how many?
2.
2. So I have x plus 1 squared over negative x plus 1. I rewrote it because we got a lot. Just second blade. And now can I take out another one?
Yeah.
So I take out another one, but I still have a negative. So it's negative x plus 1. So today you're 17 through 29 odd. And then tomorrow we're going to do the evens.
Okay.
So attempt every problem. Got it?
Attempt.
Basically, what should you do to every single problem? Factor. Every single problem you should factor, yes? And I will have a better reason on that other one. My brain shut off.